topic is the plane. So this is actually a 3D. So model equation in general form, which is ax plus by plus zz plus d equal to 0. And we also have a 3-point form, which I will give an example later on. So a intercept form is x over y plus y over b plus z over c equal to 1. So if you're looking for a distance from a point, let's say the given point is x, o, y, o, and z, o, all you have to do is just, again, now replace the variables x, y, z by the points respectively. And the distance, and all over this is actually wrong. Okay. This must be a square root of a squared plus b squared plus c squared. Okay. And the volume of the pyramid formed by the plane and the coordinates plane is just v is equal to the d cube all over 6abc. So d is this one. And we have the angle between two planes, so that's cosine theta equal to the absolute value of that one, a1 product of a1 a2 and sum of product of the sums of their a1 a2 plus b1 b2 plus c, and all over their squares, sum of their squares, and take the square root of that. So volume of the cube with two faces on a parallel planes, that is just d cube. Okay, where d, I think I already got d is this one. Okay, this d, and then again this is wrong. This must be again square root of a squared plus b squared plus c squared. Okay, let's try to answer number 1. So for number 1, answering number 1, so find the equation of the plane that passes through the points. So we have 3 points, right? So we have P1, P2, and P3, which is 3, negative 2, 1, 2, 4, and negative 2, and then we have negative 1, 3, and 2. So these are the 3 points. So we have to find the equation of that. And we have also find also the shortest distance from the plane to the point, and the volume of the solid which is bounded by the plane and the 3 coordinate planes. So we have 3 answers for this one. So the first one is we can use the 3-point form. Okay. So for the 3-point form, I'll be using, we will have something like this. Okay, and okay. So following the formula of the 3-point form, we will have here x minus x1. X minus x1, x1 is 3, right? Actually, you have here minus 3 also, minus 3, minus 3. And then this will be to x2, x3. So x2 is 2, and this is negative 1. Okay? And then the next one will have y minus y1. y1 is negative 2, so this will become now positive. And then they are all negative y1. So this is plus 2, plus 2. And then y2 and y3. Just follow the 3-point form. Okay? So y2 is 4 and 3. For the z, that is still the same, right? That's z minus z1, which is 1. Okay, so minus 1, minus 1. And then negative 2, and then negative 2, and then 2. Don't forget that this must be equal to 0, right? And then let's try to simplify this one. You will have here x minus 3, and then negative 1, and then negative 4, y plus 2, 6, 5, z minus 1 is negative 3, and 1. So be careful with this one, because this is really prone to, this problem is really prone to error. And then we have to use the MCM, or the minor cofactor method, but you have to take note that we will be expanding or using the minor cofactor method in this one, and this one. Okay, so I hope you will still remember the MCM. So applying the MCM, all you have to do is just cross out. If you are applying MCM here, so you'll be crossing this out and then crossing this out. Therefore, you will be left with this one. So, for example, that is x minus 3, okay, times, you will be left with 6, negative 3, 5, 1. So, you have to get the value for this one, or just simply get the determinant, right? And then, you have to consider this, that this is plus, okay? So, this will be the row plus column, okay? So this will become, you have a sign here which is negative 1, okay? Negative 1 raised to row plus column, okay? So for this one, that will become, the row here is row 1 and then column 1, so this will become 1 plus 1, so it will become negative 1 raised to 2, which is actually 1, so it will become just a positive. And for this one, this is row 1, column 2. So that's 2 plus 1, that's negative raised to 3, that will become negative. Okay? Therefore, simply, their signs will just be alternating. So this is positive, this will be negative, and this will be positive again. So this is positive. Okay? And then negative y plus 2, again, so it will become like this, and then like this. So you'll be left with negative 1, negative 4, and negative 3, and 1. Next is positive now. So z minus 1 times negative 1, 6, negative 4, 5. Okay. Okay. So this will become now x minus 3. I remember that this is all equal to 0, right? It's equal to 0. Now this will become 6 minus minus, so plus 15, right? And then minus y plus 2. This is negative 1, and then minus, this will become positive, that's positive 12, so negative 12, plus now z minus 1 times, that is negative 5, that will become negative negative, so positive 20, equal to 0. And then you'll have here x minus 3 times 21 minus y plus 2, this is negative 13, and plus z minus 1, this is 19, equal to 0. And then, and if you will just simplify this one, you will get something like this. So this will become the answer: 21x plus 13y plus 19z and minus 56 equal to 0. So this will be the equation that we are looking for. This is the first one. So let's try the second. Now, next question is, find also the shortest distance from the plane to the point 5, 4, negative 2. Okay. So we are also find shortest distance d, okay, from 5, 4, negative 2, right? From 5, 4, negative 2. So to find the distance, or let's say that it will be, just it will become d. Okay. So this is substitute 5, 4, negative 2 to the original equation, or the equation that we got, the 21x. So this will become 21 times 5, okay, plus 13 times 4, and then plus 19 times negative 2, okay, and then minus 56. And then make sure to, since that is a distance, there is no negative distance, and then square root of 21 squared plus 13 squared plus 19 squared, and you'll get here d equal to 2.0218. I think there's another question for number 1, right? That is the volume of the solid which is bounded by the plane and the 3 coordinate planes. We already have a formula for that, I think. Volume of the solid, which is actually a pyramid. So this will become V is equal to D cube all over 6ABC. So for the volume of that, we'll have, again, that's D cube over 6ABC. So D is 56. This is actually a absolute value because there's no negative volume. Then 6 times A is 21 times 13 times 19. So the answer for this one is 5.642. So this is the volume. So let's move on to the next number. So for the next one, we have number 2. Angles between the planes 3x minus y plus z minus 5 equal to 0 and x plus 2y plus 2z plus 2 equal to 0. So angle between this one. So A1, A2, B1. Okay. So all we have to do. So for the answer for number 2 is cosine theta equal to the absolute value of products of a's. So that will become 3 times 1, right? So we already have the equations 3x minus y. So all you have to do is just multiply the coefficients, okay? So and then plus, this is negative 1 times 2, and then plus 1 and 2, and this will become all over 3 squared plus 1 squared. Okay, so this actually only 1. You can also put a negative 1, but since it will be squared, it will just be, the negative will just be positive. Okay, and then plus 1 squared, and then times another square root of the second plane, which is 1 squared plus 2 squared plus 2 squared. And whatever the value of this one, get the arc cosine, and then the theta now will be equal to the answer. The answer is 72.4516. Okay, so this will be your answer. So next we have find the volume of the cube with two faces on the planes 2x minus y plus 2z minus 3 equal to 0, and then another one which is 6x minus 3y plus 6z plus 8. So you can actually use this formula. Volume of a cube with two faces on a parallel plane. So I already wrote it here, but as you can see, you can still write this one if you will divide everything by 3. Okay, you will have 3 times 2x minus y plus 2z plus 8 over 3, right, equal to 0. As you can see, this one and this one, they are parallel. Okay, therefore you can have here that your C2 is equal to 8 over 3. No, not C2, it is this, D2 is equal to 8 over 3, and then your D1 is equal to negative 3, right? So this one and then this one. So to get that, all you have to do is to get the D first. Okay? D. We are looking for the volume, right? But the volume is just equal to D cube. Okay. Okay. So let me emphasize that V is just equal to D cube. To get the value of D is just like when you are getting the distance between two parallel lines. Okay, so you will have here the difference of their constants, so that will become 8 over 3 minus negative 3. So those are their constants, and then the coefficients of their coefficients of x, y, z. So the coefficient is, since they are in parallel, they have the same coefficients, which is 2, negative 1, and then 2. So square root of 2 squared plus 1 squared. Again, you can just neglect the negative because it will be squared other. It will be just be squared. So the negative will just be positive plus 2 squared. Okay. So the answer for this one is 17 over 9. So V now will just be 17 over 9 cube. So this will become equal to 4913 over 729. And this will be your answer.